Hello Stationeers, welcome back to my creative world on Mars. Today I want to set up a heat exchanger that I will be using to heat gas, and this gas at 1000 Celsius I need to run Stirling engines, and the Stirling engine setup I will show in my next video. So I have here collected some air from Martian atmosphere. It has minus 40 degrees Celsius. That's not enough to run Stirling engines. This tank will be heated up to 1000 Celsius, and for that I want to use the hot gas tank from the Elmatrix furnace. The hot gas tank is at 2246 Celsius. That's too high for my taste. So the throughput through the heat exchanger, which is here, it's a gas-to-gas heat exchanger, has to be regulated. The gas flow from the hot gas tank with 2200 Celsius, well, from here, that's a green pipe through a volume pump into the heat exchanger, and the output of the first line of the heat exchanger will then go through a one-way valve into the waste tank. So that we can set up. There will the volume pump go. And I set the volume pump to 5 liter. I think that's enough. I don't want to shoot over the set point of the temperature of 1000 degree or a little bit over 1000 degree Celsius too much. Then we need black pipes that are the output pipes. Okay, and there goes a one-way valve. This is a manual valve, and it has the option to be a one-way valve. Okay, that's the setup here. Then the tank must be connected. I will connect the tank. This way. Okay. And we can connect the tank to the input of the Stirling engine, because it's the reason that I need this tank. There's the input at the back. I go with a parallel setup because then I can use as many Stirling engines as I want. If you go in the serial setup, so you feed the hot gas into this first Stirling engines and use the output to feed the next input, the output gas will be cooler than the input, and it will get cooler with each Stirling engine, and at some point it will be too cold to run the Stirling engine. So and if I set it up at this time, I can see if the pressure will be high enough. Okay, connected. Now the pressure is only 1.7 megapascal. If it's heated to 1000 Celsius, it will be much higher, maybe 10 megapascal, we will see. You can calculate it. The YouTuber Sir Kent has recently made a video about calculating and the game mechanics of gases inside Stationeers. It's a very good video, take a look there. Okay, from the Stirling engines I have the power cables run to this cable analyzer, and then through a transformer, so I can with the cable analyzer see only the power generated by the Stirling engines without going inside the room and directly have a look with the configuration card. Okay, but this video is only about heating this tank. I have a transformer here that will be used to isolate the network for the heating. There's not really much to the network, it's only the tank. Can connect it up. The tank and the pump and one IC10 with really little code in it. So let's grab the IC10, put it here, and we have to cable it up. Okay, that's all to it. Transformer is set up, 5 kilowatts. So I can set the screws, but I have to remember for the code what screw is. First screw is a tank and second will be the volume pump. We don't have any more devices on this network. Okay, the first device is a tank. The second device is a pump. I want to read out the temperature from the tank. So I go with an alias for the temperature, and that will be register 3. Then I have my setup part that will be only run if you start up the IC. So I will set the pump to off, the on variable to 0, and I will set the pump the setting to 5. The setting is a throughput that you can change with the wheel. Then we have our loop with a yield and a jump loop, so that it runs in the loop. In the loop I want to load my register temperature from the device tank, the value on the value temperature. Okay. So now in the register temperature is the value of the temperature of the tank. So then I will use a temporary register that I will set if the temperature is less than set value. So my temporary register is register 3. This will be set if the register temperature is less than 1300 Kelvin. That are a little bit over 1000 Celsius. That's near enough for my test. So the register 3 will be set to 1 if the temperature is above 1300, and it will be set to 0 if the temperature is below 1300 Kelvin. And with this value of register 3, I will set the device pump, the variable on with the value of R3. Okay, that looks to be all. Confirm, export. Let's grab the IC10 and see what happens. Oh, the pump has turned on. That's nice to see. And the temperature should be rising, and it is. Okay, if it's very slow rising, that's good for the set point of a little bit above 1000 Celsius. So for the time being I will increase it and we'll have a look at the temperature, and we can see it's going up much faster. So what happens here is the gas from the hot gas tank goes through the pump and to the radiator network, one side. That's the input temperature, 820, and that's the output, it's a little bit less. And if the pressure here is high enough, the one-way valve will open and let's gas through into the waste tank. Waste tank has 30 megapascal. Okay, we are here higher and the pressure goes up. Don't know exactly. I think I have set the set point for the overpressure pump to 35 megapascals. So now gas is taken from the hot gas tank. The pressure is going down and the ICs from the Elmotic furnace will fill it up again. Yeah, that's a nice thing. It will try to match the pressure from the hot gas tank with the waste gas tank. So, and we have there 10 megapascal to go, so it will continuously run till the pressure here is in the hot gas tank is high enough. So 800 going up. I will decrease the throughput a little bit. And over 900 I will decrease it to 5 liter. So that I will not get very high overshoot. I will get an overshoot, that's pretty normal, because this side is much hotter than the other side, and if the temperature in the gray tank will reach 1027 Celsius, the pump will shut down, but this side from the radiator is hotter, so it will equalize and heat a little bit more the gray tank. But for the purpose of the use of the gray hot tank for the Stirling engines, that doesn't matter. And as I've briefly seen, the pump for the overpressure turned slide on for a moment. Yes, I've set it to 35 megapascal. And 1027 Celsius, and the pump turned off, and the temperature will rise a little bit more because the other side of the heat exchanger is hotter, but the temperature goes down. Both sides will equalize. Okay, that's it for this video, to show you the easy use of a heat exchanger. Easy with the meaning of to set a tank or pipe network to a set value of temperature. If you only want to use the heat exchanger to equalize two networks, that's even easier than both networks you set up, like the gray one, to both sides without any regulating, and then the two gas networks will equalize in temperature. Okay, thank you for watching. I hope till the next video where I will set up the Stirling engines. Till next time.